You're listening to the Security Nexus Deep Dive, a production of the securitynexus.net. The Security Nexus is a Maryland-based national security consultancy. We specialize in strategic advisory, education, and public engagement. Through podcasts, blogs, training, and consulting, we provide insight into the evolving landscape of cyber threats, hybrid warfare, and strategic security policy. Our mission is to inform, educate, and empower both professionals and the public through clear, accessible, and actionable knowledge. Today, we're diving into the world's oceans, where there's this silent, high-stakes game of hide-and-seek being played every single second. It's not a game of submarines and destroyers anymore. It's a battle of data, satellites, and algorithms. In this explainer, we're going to break down how technology is trying to make the seas completely transparent and how some are using some pretty incredible deception to stay hidden in the shadows.
So how are we going to tackle this? We've broken it down into 4 parts. First, we'll look at the tech that created what we call the transparent ocean. Then, we'll dive into the ghosts in the machine. That's all the ways ships try to disappear. After that, we'll uncover the eyes in the sky that are used to hunt them down. And finally, we'll look at the fused future and how all this data comes together to paint one clear picture.
You know, for most of human history, the oceans were the perfect place to hide. They're just so vast, so empty, so mysterious. But in the 21st century, a new technology started to change all of that, and it promised to make everything happening out at sea visible to everyone, everywhere.
And that technology is called the Automatic Identification System, or AIS. As researcher Kashif Talpour explains in his work, AIS is basically a radio system that's mandatory for large ships. They constantly have to broadcast key bits of info, like who they are, where they are, and where they're headed. It was set up by organizations like the International Maritime Organization, really for one main reason: safety, to help ships see each other and avoid collisions.
And you can see how it works right here. A ship's AIS transponder pings out a signal to other ships nearby, to stations on the coast, and, this is the crucial part, up to satellites. This creates a massive global network, almost like a digital map of the oceans that tracks thousands of vessels in near real time. In theory, this should make the ocean totally transparent.
But all that transparency depends on one really important thing: everybody playing by the rules. The system only works if everyone is broadcasting honestly. And that brings us to the heart of our story today: what happens when a ship decides it doesn't want to be seen.
So why would a ship want to hide anyway? Well, shady business loves the shadows. We're talking about anything from illegal fishing in protected waters, to smuggling, to ships trying to violate international sanctions by secretly transferring oil out at sea. For these folks, AIS isn't a safety tool, it's a huge liability.
So to get around it, they use 2 main tricks. The first one is super simple: going dark. As researchers like Yuan Shao have documented, this is when a ship's crew just turns their AIS transmitter off. And poof, they literally vanish from the map. The second method is a bit more clever. It's called spoofing. This is the art of digital lying. Instead of just disappearing, a ship will broadcast false data: a fake name, a fake position, or maybe even the identity of a totally different ship that was scrapped years ago.
And this is where it gets really fascinating, because it shines a light on the system's biggest weakness. A paper by Anna Anchik and her colleagues just nails it. They wrote, "The data sent by the transponders are simply not subject to any control or verification of their integrity." Think about that. The AIS system was basically built on a handshake deal, a system of trust. It has no way of checking if the information it's receiving is actually true. It just takes the data at face value.
And this weakness can be exploited in some pretty dramatic ways. Take a look at this image from that same study by Anchik. It shows a real event from 2019 near the island of Elba in Italy. All of a sudden, navigation screens in the area were just flooded with a cloud of thousands of fake ship signals. It created complete chaos. We're still not 100% sure what caused it, maybe some kind of electronic warfare test, but it's a perfect example of just how easily this system can be manipulated.
Okay, so if the main tracking system can be turned off, or just plain lied to, how in the world do you find these ghosts? Well, the answer is you have to look for evidence that can't be faked. And this is where a whole new generation of satellite surveillance comes into play, creating some powerful ways to see right through the deception.
A crew can flip a switch and become a ghost in the public tracking system, thinking they're totally invisible.
But what they can't go is turn off the laws of physics. See, even without AIS, a modern ship is buzzing with electronic activity. It's still using things like navigation radar, satellite phones, all of which give off radio frequency, or RF signals. And our satellites can hear those signals. This image shows an analysis that did exactly that.
It found clusters of RF signals near the Galapagos that didn't match up with any AIS records, revealing a whole fleet of potential dark vessels.
RF geolocation is just one tool in the toolbox. The real game changer is arguably synthetic aperture radar, or SAR. SAR satellites don't really take pictures in the way we think of them. They send out a radar pulse and then build an image from the echo that bounces back. And what that means is they can see a ship's actual physical metal hull on the ocean surface, day or night, and even right through thick cloud cover. And then, of course, you still have traditional optical satellite imagery, which is basically just taking a really high-resolution photo from space.
So how big of a problem is this, really? Are we talking about a few bad apples? Well, according to a 2024 study led by a researcher named Yuan Chao, a staggering 75% of the world's industrial fishing vessels are estimated to be operating outside the AIS network. Let that sink in. That's a massive, unmonitored fleet, and you can bet a lot of them are hiding their activities for a reason.
So, let's recap. We have AIS data, which might be a lie, and we have satellite data that's real, but doesn't have an identity attached. No single sensor can tell you the whole story, so the ultimate solution isn't to rely on just one system, but to intelligently combine, or fuse, all the data you have into a single clear picture of what's actually happening out there. And wow, this is not a simple job. This flowchart here from a paper by Chenji Zhao and his team gives you just a little taste of how complex it is. You've got visual data, AIS signals, GPS data, all coming in different formats. The real future of watching the seas is in building systems that can automatically take in all this noise and make sense of it all.
But at its heart, the logic is actually beautifully simple. We can break it down into 4 steps. Step 1. Use things like SAR and RF to find every physical ship in a specific area. Step 2. In that same area, listen for all the AIS signals being broadcast. Step 3. Now you play matchmaker. You correlate the physical ships with the broadcast signals. And step 4 is the big reveal. Any physical ship that your satellite sees that does not have an AIS signal broadcasting from it gets flagged as a potential dark vessel.
Of course, trying to do this manually across the entire planet would be completely impossible. The amount of data is just overwhelming. And this is where, as researchers like Talpor have highlighted, artificial intelligence and deep learning become absolutely essential. You need incredibly powerful algorithms to sift through mountains of data in real time, automating that search to find the one suspicious needle in a global haystack.
And this really brings us to our final thought. We've seen this evolution from simple AIS tracking to this complex, multi-layered surveillance network that's powered by AI, but you have to remember, this is a perpetual cat-and-mouse game. As the technologies for finding ships get more and more powerful, you can be sure that the techniques for hiding them will evolve to try and counter them. The game of hide-and-seek at sea is far from over. If anything, it's just entering a new, much more high-tech chapter.